In this introductory video, I will introduce how you can integrate maker concepts into your academic projects. So what is making? You may have heard about the maker culture or the maker movement. The maker culture or the maker movement is about learning practical skills and using them to create and invent. Makers use new technology such as 3D printers and computers, as well as more traditional activities such as metalworking, woodworking, and arts and crafts. Making is not just about being able to do it yourself, but also about being able to work with a community and do it together. The maker culture puts a lot of emphasis on learning through doing, so it works great with project-based learning. These short videos will help you to understand how to integrate maker concepts into academic projects. What do I mean by integrating maker concepts into academic projects? I'm referring to teaching an academic objective as well as a maker concept. It can often be the use or application of making and creating to reach a learning objective. When trying to integrate multiple concepts into your teaching, it is important to understand that there are different levels of integration. There is a spectrum of integration. On one end, there are shared activities. On the other end, there is conceptual integration. This is our goal. Shared activities is when we add in an activity that doesn't teach the concepts and is not assessed. This is really a very light introduction to a concept, skill, process, or tool. For example, when our school first got a 3D printer, my history class used it to print game pieces for their history games. While they did get to try out the new printer, they weren't held accountable for learning actual skills required for the 3D printer. This was just an activity that used the 3D printer. Getting to conceptual integration is not so much about what you do, but how you do it. To fully integrate a maker concept into academic projects, the maker concept needs to be part of the learning goal. It needs to be related to real-world applications, it needs to be assessed, and it needs to be taught. For example, with a little bit of foresight, I could have fully integrated concepts around 3D printing into the project for making games about history. I could have made it part of the learning objective with a driving question such as, how can we use 3D printing technology to create games that teach history? I could have made sure students learned real-world skills for the 3D printer, even if they were very basic or introductory skills such as finding, scaling, and 3D printing objects. I could have assessed students' abilities to use an efficient process to find relevant items to print, use mock-ups to determine the proper size of the final pieces, and use 3D printer software to scale the items to the appropriate size. And in order to assess these skills, I would have taught or provided opportunities to learn each of these skills and integrated them into our project. In doing so, students would have learned important history concepts as well as valuable 21st century skills, enhancing their own abilities to make and create. As a teacher, I would have gotten much more out of a single project and would have valuable data showing that students learned important skills. In the next 4 videos, I will show you how to come up with a learning objective that is suitable for both academics and making, how to relate real-world making concepts with academic standards, how to create assessments for these integrated projects and maker concepts, and how to outline and integrate teaching the maker skills into your projects.